Okay, back to hydrocarbons. So this, starting now, if you want to put a star there, I'm considering it a little honors section. It does involve little memorization, but I think you'll catch on easily. So here's what you need to know about hydrocarbons. Of course, organic, and they are polymers. Most of them are long chains. All right, they also do not contain any lone pairs. That is going to make them very easy to draw, because you won't need to add up any valence electrons, figure out how many lines you need to draw. You're going to be limited by simply knowing that every H, hydrogen of course being small, only needs one line touching it. Remember what a line represented anyway?
A bond.
A bond of 2 valence electrons. Good. And they're shared in covalent bonds. So 2 valence electrons are shared between hydrogen and carbon here. But of course carbon, being a little bigger, needs 4 lines touching it. So as long as you have 4 lines touching every carbon and 1 line touching every H, then you will have drawn it correctly. Also, there are often more than one right answer. If I ask you to draw a certain hydrocarbon, there are isomers of a lot of these. Well, almost all of them except the small ones. Which means they're the same chemical formula. Like these are all C5H12, but they are different looking, right? They're different structural formulas. So that kind of makes it easy too. More than one way to draw a lot of these. We, for simplicity, will probably just draw them all as long chains. Okay, we saw that picture. All right. So there are 3 endings you can have. You saw some of those names already. The ones that end in ane, A-N-E, they're called the alkanes. Alkanes, really easy to draw. They all have single bonds. So if you see an ane in the name, you know it's going to have single bonds. And the fact they all have single bonds means they have the maximum possible number of hydrogens, so they're considered saturated. They fit this formula, whatever that means, CnH2n plus 2. Okay, what does that mean? When you're looking at a hydrocarbon, you're going to look at the number of carbons and the number of hydrogens. You're always going to double the number of carbons. Okay, so here's an example, C3H8. Okay, so I'm trying to figure out, is this an ane, an alkane, maybe an alkene, or an alkyne? So C3H8. Take the number of carbons and double it. So what's double 3? 6. Okay, and then you compare that number to the number of H's. Is it 6? No. How do I get from 6 to 8? It must be a... If you double it and it's plus 2, that's an alkane. So the name should have ane at the end. Let me go through the notes and I'll do a few examples here. So here's your prefix list. And we're only going to go up to 10. And you actually know some of these already. The first 4, though, are a little different than the covalent prefixes we already learned. But does pent look familiar? Hex, hept, oct, non, dec. Those are all hopefully familiar to you, and they mean the number of carbons you have. So like, pentagon, 5 carbons. Hexagon or hex, you know that means 6. But you might want to write this for the first. This is a little trick I used to have a Mary Elizabeth. And she played basketball. M-E-P-B. Mary Elizabeth plays basketball.
Who plays basketball?
Mary Elizabeth plays basketball.
Where's the PH for?
She unknown, 34 maybe.
Mason Ethan played basketball.
If you would prefer a different acronym, go right ahead.
What?
M-E-P-B. Now you still, of course, need to remember, okay, M, think meth, F, prop, and bute. So that's the memorizing part. You do need to know the 10 prefixes: meth, F, prop, bute, pent, hex, hept, oct, non, dec. All right, the enes. Same prefixes. We still have meth, eth, prop, bute, but we could put an ene on the end. Meth, well, except thene, propene, butene. And there you can tell if you have an ene because all you do is double the carbons. So same thing. Now we could not have methene because the enes have a double bond. And you wouldn't have a double bond with an H. So methene just simply won't work. The double bond has to be between two carbons. You have to have at least two carbons. So sorry, we had yet another audio failure, so I'll do another quick voiceover for the rest of these notes. But we were talking about the alkenes, and you can just check the formula again. As you see up here, for every one carbon you have, you'll have two hydrogens. So the hydrogens should always be double the carbons for the alkenes. And you have all the same prefixes, they just now, of course, end in ene. Ethene, propene, butene, pentene, etc. So you can check pentene real quick. You know, it's got 5 carbons, double that's 10, fits the formula. Alkynes, on the other hand, fit the formula. Hydrogens are going to be double the carbons, but this time there's a -2. So you can check with this example, C3H4. You would always double the carbons, so double 3 is of course 6. And then to get from 6 to 4, we would have to have a -2. So whenever you have a -2, that's an ine, an alkyne. And alkynes have 1 triple bond. And you can check another example, you know, instead of pentene, like we just had a second ago, we have pentyne, which is C5H8, fits this formula. You know, double the carbons, okay, double 5 is going to be 10, but to get from 10 to 8, I would have to have a -2. So whenever you see a formula like this, you would know it would have to be an ine. So that's pentyne. And those are, of course, hydrocarbons. Another topic that we're just going to touch on briefly is substituted hydrocarbons. Substituted hydrocarbons, sort of what it sounds like. Something is substituted for another element or group of elements. And that's where we substitute a hydrogen. So alcohols are a perfect example, where we have ethane as a hydrocarbon. Eth, you know, will be your 2 C's, and then an ane is going to be double the carbons plus 2. So 2 C's doubled is 4, plus 2 would be 6. You can double check that. 1, 2, 3, 4, 5, 6 H's. So that's ethane. But if we were to swap out one of those H's with an OH, for example, that's going to make it an alcohol. So now we can have ethanol. And you could have that whole list as well. Propanol, butanol, pentanol, you know, etc. So those are substituted hydrocarbons. Another topic in organic is aromatic compounds. Aromatic compounds, as we mentioned, you know, sort of smell, sort of got the word aroma in there. They contain a benzene ring, which is this carbon and hydrogen structure where you have a double bond for in between every other carbon. And it's often just drawn as this. I really won't ask you anything else other than knowing that aromatic compounds have a benzene ring. And of course they are organic. Okay, now if you missed this day of notes, I would like you to copy this little chart down. Just a little bit of practice with the hydrocarbons. Given any one of these 3 things, you should be able to come up with the other 2. So if I gave you the name of the hydrocarbon, you should tell me what the formula is, and then you should be able to draw it. You should be able to give me that structural formula. So we'll do one example of each. We'll start with apparently hexyne. So if I gave you the name hexyne, you know, how would you come up with the formula? Well, of course, these are hydrocarbons. You got the anes, enes, and ines are hydrocarbons. You know, it's just going to be C's and H's. But the ine, you know, is your clue that it was part of that formula. Double the carbons minus 2. Well, how many carbons are there? You're going to get that from the hex. And hexagon, that should be an easy one. That, of course, means 6. So we know we have 6 C's, and then double minus 2 for a Y and E for an ine. Double 6 is 12, minus 2 would have to give us 10. So hexyne is C6H10. then of course I'd want you to draw it. Well, it'd be difficult to draw without knowing the formula. And while there are isomers of hexyne and these other hydrocarbons, I want you to stick with a chain. So just draw 6 C's in a chain to start. And start them off all single bonds, but we'll come back and look at that. So 1, 2, 3, 4, 5, 6. Got our 6 C's, and then we do need to remember that by definition, a YNE means that there is a triple bond in there. And we can't have a triple bond with the H's, it's got to be between the C's, because hydrogen, of course, could only have one line touching it. And that's really your choice. Pick any of the C's to make a triple bond between. I did it right smack in the middle here, but with isomers, there is more than one correct answer here. So all the rest of the little slots, basically you're filling in with H's, and that way, of course, each carbon will have 4 lines touching it. And always, always a good idea to go back and double check your rules when you're done. So I've made my picture, double check, do I have 6 C's? Yes. Did I actually draw 10 H's? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Check, I did that. And do I have 4 lines touching every carbon? I do for this one, I do for this one. This one is fine too. It's got 3 on the right, 1 on the left. This one's got 3 on the left, 1 on the right. That's fine, that's fine. So we have followed all our rules, and that is a perfect example of hexyne. Okay, as another example, if I give you the formula, you need to be able to come up with the name and the structural formula. So, okay, so naming this, we've got obviously 3 C's, 8 H's, and so I'm just going to kind of see how do I get 8 from 3. Well, I always start by doubling the C's, so 3 doubled is 6. So doubling the C's gives me 6, and how do I get from 6 to 8? Well, I'd have to add 2. And if you're adding 2, that's always an ane. So I kind of came up with the back of the word first, and then the 3, third on my list. You might want to say try, but that is slightly different for the hydrocarbons. 3 was, Mary Elizabeth played. That's the p-meth-eth-prop, propane. So this is simply the formula for propane. Drawing it out, just give yourself 3 C's in a row, and double check, if it's an YNE, an ine, or an ene, it's going to need a triple or double bond. But anes are all single bonds, so basically just fill in all your gaps with H's. And of course double check that you did draw 3 C's and 8 H's, 1, 2, 3, 4, 5, 6, 7, 8, and double check that each carbon has 4 lines touching it. Looks good for that one. Lastly, you should be able to take a structural formula and come up with the formula and the name. So the formula is very straightforward. Just count what you have. Count the number of C's, count the number of H's. So in this example, I've got 1, 2, 3, 4, 5 C's. So it's got to be C5, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 H's. So C5, H10, just from counting the C's and the H's. Another sort of shortcut to that is if you see a double bond, well, a double bond comes from an ene, so as soon as you knew there were 5 C's, you would automatically know, well, double that for the H's have to be 10. And like I just said, that's an ene, so the end of this is going to be ene, and 5 from your prefix list is pentagon. So this is pentene. Okay, so for test or quiz, you should be able to, given either the name, the formula, or the structural formula, come up with the other 2.